Dear students, good morning. Today we'll start paper 2, that means chemistry paper 2 under that physical section. Okay. So under physical section, the first one is macromolecular chemistry or macromolecules. Okay. This is the lecture 1 under paper 2. So macromolecules, the name itself indicates macro, very big molecules, and which are also known as polymers, and which are having very high molecular weights, and they are covalent compounds, usually covalent compounds. Okay, so now they are said to be polymers because it's a Greek word. Poly means many, meros means parts. So the macromolecules which are made up of many parts, that means the polymer is a macromolecule which is made up of number of repeating units, and they are said to be monomers. They are said to be monomers. So with this, say, based on their origin, based on their, say, source from which they are obtained, they are classified into two types. One is natural polymers and the second one is synthetic polymers. So the natural polymers are the one which are obtained from, which are extracted from plants or animals. Okay, they are said to be natural polymers, which are naturally occurring, naturally present in the, say, environment. We can give the example, say, starch, cellulose, silk, wool, gum, resins, rubber, etc. So they are the examples for natural polymers. Second one is synthetic polymers. Synthetic polymers are nothing but man-made polymers or artificial polymers which are prepared in the laboratory or in industries. So even here we can give the number of examples, like say polyethylene, polystyrene, polyvinyl chloride, Teflon, nylon, Terylon, terracotta, etc. So, okay, so these are the examples for synthetic polymers. Now, with this, next one is polyreactions. Say polyreaction is nothing but it is the process of manufacturing polymers. It's a process of manufacturing or preparing a polymer or macromolecules is said to be polyreactions. So under this there are two types. So one is addition polymerization reaction or chain polymerization reaction. Second type is condensation polymerization reaction. That means the polymerization reaction, either it may follow addition polymerization reaction or it may follow condensation polymerization reaction. Okay. Now with the first one, say under addition polymerization reaction, so you have mentioned the four examples which are to be prepared according to addition polymerization, or the preparation of which compounds are as per the principle under addition polymerization process. Okay, so now here a simple example. When n number of ethylene is subjected to polymerization reaction, okay, so it gives a long chain, or it is a macromolecule, and which is said to be a polyethylene. Say n is the huge number, more than thousands or lakh. So when they are subjected to polymerization, it results in a formation of a huge molecule or a giant molecule or a macromolecule which is said to be a polymer, and the name of this one is polyethylene, where the monomer is ethylene. So in the beginning you have understood polymer is made up of many number of repeating units. Now here ethylene is a monomer when it is repeatedly connected to one another or it is added to one another. So the resulting molecule is polymer. Okay, and here it is the monomer. Okay, now under polyethylene, there are once again two types. One is low density polyethylene and the second one is high density polyethylene. So high density polyethylene, it is denoted by HDPE. Low density polyethylene, LDPE. Okay, so now say in both the case the monomer is the same, Monomer is ethylene, that is CH2 double bond CH2. So, but the condition of the reactions are different. Say in LDP, in the preparation, that means in case of low density polyethylene, when n number of ethylene molecules are subjected to polymerization. Say the condition of the reaction is the temperature is around 350 to 570 Kelvin and the pressure very high pressure 1000 to 2000 atmosphere pressure, and in presence of catalysts like initiators like oxides or peroxides. Say the compound resulting compounds are said to be low density polyethylene. So they are the polyethylenes and which are said to be low density polyethylene, and the density of these compounds are in the range of 0.91 to 0.94 gram per cm cube. Okay, so now say the low density polyethylene, they are chemically inert, they are insulators, and they are thermoplastics, and they are the first grade polyethylene, and which has got, and even now, that means it is prepared in the year 1933, first time it is prepared in the year 1933, and now even still now it has got very good value, market value, because it has got a very large field of applications, that means uses, very large uses. So they are used in the say preparation or making plastic bags, film wraps, then electrical wires, pipes, toys, many number of household or day-to-day life using utensils or say wares, housewares. Okay, so this is about low density polyethylene. So regarding the preparation, this will be the condition, and density is in this range, and it is a thermoplastic and first grade polyethylene, and which has got very importance in day-to-day life, even till today. Okay, even till today. So the second type is HDP, high density polyethylene. So even here also the raw material or the say monomer is ethylene. When n number of large number of ethylene is subjected to polymerization. Now here the condition is, say the temperature is in the range of 333 Kelvin to 343 Kelvin and the pressure 6 to 7 atmospheric pressure, and in presence of Ziegler-Natta catalyst. Ziegler-Natta catalyst is nothing but it's a mixture of Al, Et thrice. Et stands for ethyl, triethyl aluminium, Al, C2H5 thrice or Et. You know this notation. Et stands for C2H5. C2H5. So now here 3 times triethyl Et3 is Al Et thrice plus TiCl4. This catalyst is said to be Ziegler-Natta catalyst. So in presence of Ziegler-Natta catalyst at this temperature range and 6 to 7 atmospheric pressure, when the ethylene, number of ethylene molecules are subjected to polymerization, it undergoes radical polymerization and free radical polymerization and results in the formation of a macromolecule, and this is the partial structure of the polymer, partial structure it is of polymer, and density of resulting molecules are in the range of say 0.941 gram per cc or greater than it. Okay, they are said to be high density polymer polyethylene. And now out of these two, the first one LDP is having high branched chains in the molecule, but here low branched chains in the molecule. Both of them are chemically inert, both of them are very good insulators, and they are the thermoplastics, and hence they have got a many number of uses. That means they are very much important in its applications, in their applications, and even these polymers are used as a say making bottles, plastic bottles, tubs, milk jars or milk jugs, then water pipes, garbage containers, toys, etc. So even in many number of household wares, in the manufacturing of many number of household wares. So HDPE is used. So with this we'll move on to the next one. Say the second one, polystyrene. Okay. So the first one is polyethylene. Under that you have come across two types of say polymers, that is HDP, LDPE and HDPE. And now the second example we can say polystyrene. Polystyrene. And polystyrene is an aromatic compound, that means which contains benzene ring, and it is hydrophobic, that means geophobic, or you can say it is hydrophobic. And once again it's a covalent compound, and which is also prepared by polymerization or addition polymerization reaction. And once again it is a polymer, and here the monomer is styrene is the monomer. Styrene is the monomer. So the structure of styrene is say CH2 CH benzene ring. So it is a styrene. So when the styrene, say n number of styrene, when it is subjected to polymerization, so you will get a big molecule or a polymer which is having the formula. Okay, so like this will be continued. So it is a polystyrene. This one is a polystyrene. And here when it is subjected to polymerization, and usually peroxides are used as a catalyst. Peroxides are used as a catalyst. And there is one more reaction, second type, where instead of peroxides we can use butadiene. Butadiene, say, as a catalyst. It is a butadiene. Okay. So once again you will get the polystyrene. So this is one method, and this is the second method of preparation of polystyrene. So now polystyrene is a transparent polymer. See, this is a transparent polymer. Transparent polymer which has got very good say optical properties, and its refractive index is also quite high. Okay. So now with once again it is an insulator, bad conductor of, that means electricity. Insulator means bad conductor of electricity, and it is inert, chemically inert, and it has low melting point. It has low melting point, and so melting point, and based on the properties of say this polymer, they are used in making say thin sheets, jars, bottle caps, cups, and storage containers, and even audio cassettes, and also television parts, in making television parts. So this polymer is used. Okay. So with this we'll discuss in the next class. Thank you.